Today's lesson is rational functions and their asymptotes without using a calculator. Okay, let's start with what's our learning goal. Today I can graph rational functions by factoring, simplifying, and solving for intercepts and asymptotes. To start out with, by definition, a rational function is a function that can be written as the quotient of two polynomials where d of x cannot equal to 0. So I call the polynomial in the numerator function n and the polynomial in the denominator function d. So we're talking about rational functions. So the parent function for a rational function, let's just review. So the equation is f of x equals 1 over x. And it looks like this. Okay, so this is the parent function. And I have asymptotes on the x-axis and the y-axis. And an asymptote is a line that I approach that I never go across. Okay, and n, the lowercase n, represents the degree. M is the degree of the denominator. So n is the degree of the numerator and m is the degree of the denominator. Okay, some basic directions. I have them all kind of written down. There's a lot of directions. I don't think they're hard. It's just a lot of steps. Okay, first, factor the numerator and the denominator if possible. Simplify the numerator and denominator if possible. The removable factors are called removable discontinuities. Another name for that is called a hole. Okay, so we're moving to pre-calculus, so they're called removable discontinuities in pre-calculus. Okay, to find the x-intercepts, we're going to set each factor in the numerator equal to 0 and solve for x. And the coordinates will be in the format of a number where y is 0. To solve for the y-intercept, I'm going to substitute x equals 0 and solve for y. And the coordinate will be 0 and any number. So x is 0 for a y-intercept. Okay, vertical asymptotes are where the function are undefined. Undefined means discontinuous. This is where we're going to put the asymptotes. We're going to place vertical lines where the x coordinates make the denominator equal to 0. So where the denominator equals to 0, I'm going to put a vertical asymptote. Horizontal and slant asymptotes, I have one or the other, not both. So the end behavior of my rational function is determined by the degree of the exponents in the numerator, n, and the denominator, m. We said those are the degrees. So when the degree in the numerator equals the degree in the denominator, I have a horizontal asymptote, and it's at the location of the coefficients of the leading terms. If the degree of the numerator is less than the degree of the denominator, I have a horizontal asymptote at y equals 0. And if the numerator degree is greater than the denominator degree, then I have a slant asymptote. And the slant asymptote is, we're going to be using y equals mx plus b, so it's going to be a linear equation, and then we're going to use synthetic division to find that. So the removable discontinuity, also known as a hole, this is where I'm going to set the removable factor. So whatever I could simplify that was in the numerator and the denominator, if I have one, I'm going to set that equal to 0 and solve for x. And then I'm going to substitute x into the simplified equation in number 2 and solve for y. This is where the hole will be. So I'll have a coordinate. Okay, I have 3 examples that I'm going to go through here. I think there's just a lot of steps, but I don't think they're real hard. Okay, graph the rational function based on the key attributes. So my equation is f of x equals 3x divided by x squared plus x minus 2. So the first thing says factor the numerator and the denominator. So I'm going to factor. So I have f of x equals 3x. And factoring the denominator, I'm looking at, since a is 1, I want the factors of 2, which are 1 times 2. My signs are opposite, and the larger one is positive. So this is going to be x plus 2 and x minus 1. Do I have anything to simplify in the numerator and the denominator? No, so that does not apply. For the x-intercepts, this is where I am going to set the numerator equal to 0. So the numerator is 3x. So this is 3x equals to 0. So solving for x, I get x is 0. So the coordinate is going to be at x is 0 and y is at 0. Right, so I'm going to plot that point. So that's at the origin, right? My y-intercept, this is where I'm going to set x equal to 0. So this is going to be 3 times x. So this is f at x equals 0. So 3 times 0 divided by 0 plus 2 and 0 minus 1. So 3 times 0 is 0. So anything times 0 is 0. So my y-intercept is at 0, 0, and I already have that plotted. Next, I want to know where do I have vertical asymptotes? Vertical asymptotes are where the denominator factors are set those equal to 0. So I have x plus 2 equal to 0. So x is negative 2 and x minus 1 equals 0. So x equals 1. So these are my vertical asymptotes. So I'm going to draw those in at negative 2 and at 1. Okay, so I have these at 2 and negative 1. All right, next I want to know, do I have a horizontal asymptote or a slant asymptote? So looking at what are my values of n and m, so I'm looking at, I see that n is 1 and m is 2. So n is less than m, so I have a horizontal asymptote. So I don't have a slant one, I have a horizontal one. So this is where n is less than m. I said n is 1 and m is 2. So that tells me my horizontal asymptote is at y equals 0. So that's the, x-axis. So I'm going to draw that in. So I'm going to write what these are. That's really what I see. Y equals 0, x equals 1, x equals negative 2, because I'm going to expect you to draw these in. So I'm going to make sure you see that. Okay, so last question is, do I have a hole? No, this does not apply because I did not have anything that I simplified. So this does not apply. I had no removable factors. Okay, no removable factors. Okay, so I want to know how to graph the middle. And to graph the middle, I have to test points. So right now I have 3 different sections on my graph. So I have a section from here to here, an interval from here to here, and an interval from here to here. So I need to test a point in each section to know if I'm going to be in the top or the bottom of that section. So it doesn't matter what x value I pick in the interval. So I'm going to pick one that's a little simpler. Here I have one. So this is where I'm going to go across. I can kind of figure out I'm doing this, but I'm going to do some points so I can see it. So I'm going to call this interval 1, this interval 2, and this interval 3. So I'm going to pick a point, test it, and then I want to see am I above or below the horizontal asymptote, and then I'll know where to draw my graph. All right, so I'm going to start out with, I'm going to pick the point at x equals 2. It doesn't matter, I can pick any number greater than 1, but I'm going to test at x equals 2. So I'm going to substitute in f at 2 equals 3 times 2 over 2 plus 2 and 2 minus 1. So this is going to be f at 2 is going to be 6 over 4. So 2 times 6. So this is 6 and 2 plus 2 is 4 times 1. So that's 6 over 4. So 6 over 4 is 1.5. So f at 2 equals 6 over 4, which is 1.5. So my point is 2, 1.5. So I'm going to plot that. So my point at 2, 1.5 is here. So I know I don't go across the asymptote, so I know I'm in the top part. So I'm going to do the same thing for the other 2 intervals. So I already have 1 point here at 0, so I'm going to test at -1 because I want to know if I'm, above or below.
Pre-calculus.
Nope, I don't want this. There we go. Sorry about that. Okay, so next, I'm going to test at x equals -1. I'm going to do the same process. So at x equals -1, so f at -1 is 3 times -1 and -1 plus 2 and -1 minus 1. So -3 times, or 3 times -1 is -3. And -1 plus 2 is 1 times -2. So this is over -2. So negative divided by negative is positive. So this is positive 1.5. So my point is at -1, 1.5. Okay, so I'm going to go plot that point. So -1, 1.5. Oops. So -1, 1.5. Oops. Okay, so I look like this. And then my last one, I want any number less than -2. So I'm going to just use -3. So x equals -3. So f at -3 equals 3 times -3 divided by -3 plus 2 and -3 minus 1. So -3 times -3 is -9. -3 plus 2 is -1 times -4, so that's +4. So -9/4 is -2.25. So my point is at -3, -2.25. So I'm going to go plot that one. So -3, -2.25. So I really want to know basically, am I above or below this horizontal asymptote? So I know which section I'm plotting in. Okay. All right. And you kind of have to just kind of plot a couple of these to get the hang of them. Okay, so that was the first one. Let's try 2 more examples. Oops. All right. F of x equals x squared minus 9 divided by x squared minus 2x minus 3. So first thing I want to do is factor. So this is f of x equals, this is a difference of squares, so this is going to be x plus 3, x minus 3. And then factoring the bottom, they're the factors of 3. So x plus 1 and x minus 3. Next step says simplify. I have some factors in the numerator and the denominator. So my simplified equation is f of x equals x plus 3 over x plus 1. So for my x-intercepts, I set the numerator equal to 0. So this is x plus 3 equals 0. So x equals -3. So my point is -3, 0. So -3, 0. My y-intercept, I am going to set my equation, the x equal to 0. So this is f at x equals 0. So this is going to be 0 plus 3 over 0 plus 1, which is 3 over 1, which is 3. So my point is x is 0, y is 3. I'll plot that one. Next, I want to find where my vertical asymptotes are. My vertical asymptotes are, and I'm using the simplified equation. So this is that x plus 1 equals 0. So x equals -1. So I'm going to go put my vertical asymptote in. And then I want to decide, I'm looking at n and m. So I see that n is 2 and m is 2. So the degree of my numerator equals the degree of my denominator. So I have a horizontal asymptote, not a slant asymptote. So my degrees are equal. So n equals m. So we said they're both 2. So this is where I'm using the coefficient. So this is where I'm going to take the coefficient a sub n over b sub m. And the coefficients in here are both They both happen to be 1. So it's going to be 1 divided by 1. So 1, oops. So 1 divided by 1. So this is at y equals 1 is my horizontal asymptote. Okay. And we do have a hole in this one because we had this removable discontinuity. So this is where I start by taking that removable discontinuity, which is x minus 3. Oops. X minus 3. Set that equal to 0. So x equals 3. And then I put this in the simplified equation. So f at 3. So I'm going to use that x equals 3. Is 3 plus 3 and 3 plus 1. So this is 3 plus 3 is 6 divided by 4, which is 3 halves or 1.5. So my whole is at 3, 1.5. So let's go put that in there. So at 3, 1.5. So I'm going to draw a hole. 3, 1.5. So I'm going to draw a hole. Okay, this one I only have 2 intervals. And I know the basic shape of a rational function looks like this. So I already have 2 points in the top right-hand quadrant and 1 point in the bottom left-hand. So I really don't have to test for any points. So I already have information. So I don't need to test any. Okay, so what I do want to point out is the denominator either has vertical asymptotes or holes. Okay, so and the numerator is the x-intercepts. Okay, so last one with a slant asymptote. Let's do one more example. Okay, first step is factor. So I can take out the greatest common factor in the numerator. So this is f of x equals x times x minus 1 over x plus 1. I have nothing to simplify, so this does not apply. So for my x-intercepts, this is where I set the numerator equal to 0. So this is x equals 0, so I set each factor, and x minus 1 equals 0. So I already have one x-intercept here. So that's going to be at 0, 0. And this one is at x equals 1. So this is 1, 0. So let's go put those on. I have one at 0, 0 and one at 1, 0. Okay, so the y-intercept. So this is going to be f at x equals 0. So this is going to be 0 times 0 minus 1 over 0 plus 1. And 0 times anything is 0. So my y-intercept is the origin, and I already have that plotted. My vertical asymptotes are where the denominator is 0. So this is x plus 1 equals 0. So x equals negative 1. Next, I want to see what the degrees are. So the degree of the numerator, so n equals 2. And the degree of the denominator, m equals 1. So the numerator's degree is larger than the denominator's degree. So that tells me I have a slant asymptote. So when n is greater than m, so 2 is greater than 1, I have a slant asymptote. So this is where I'm going to use synthetic division to divide to find where my line is. So in my equation up above, I have a missing factor. So this is really plus 0. So I need to put a placeholder there. So I have my coefficients are 1, -1, and 0. And I'm dividing by -1. So I have 1, -1, and 0. And I'm dividing by -1. So I'm bringing down my first coefficient. -1 times 1 is -1. Add down, I get -2. -1 times -2 is +2. Add down, and I get 2. And I don't really care about what the remainder is. This is my equation of my slant asymptote. So here I'm at, these coefficients are squared. So this row of coefficients is the linear equation. So this is at y equals x minus 2. So I need to go graph that. So this is y equals mx plus b, where my slope is 1 and my y-intercept is -2. So I'm going to go, my y-intercept is -2 and my slope is 1. So I know I have these points right here. Okay. Okay, so it looks like this. And again, I have some points here already, and I cannot, and I'm in opposite quadrants. So I don't need to check anything because I have something saying I'm already in this quadrant. So if I'm in this one, well, I guess you could check, but I know I'm over here. Okay, that's it.